I have to start my screen sharing. So let me share my screen first. Where is the screen sharing? So I believe my voice is pretty clear for everyone. I can't come to this window hereafter, so please ensure that my voice is clear. And I also believe that my screen is visible to everyone. Okay. So my recommendation is, I think you guys can go and pin this one, the presentation which you are seeing here. If you click this pin, it will hang on in the screen. Okay, so by that you don't get sparked. Okay. So I think so. This is the agenda. I believe all of you may have got some kind of an PDF image or something where you may have found certain topics and all that. So today we are going to see the execution of a container-based CI/CD pipeline. So this is the topic. So before I go through, one by one topic and explain and complete the whiteboarding and hands-on and all that, you guys need to hold some patience. Suppose if you have questions, we'll have a very elaborate question and answer time or discussion time where you can ask everything. But my recommendation is please note down your questions. Okay. So by that, it will be very easy for you to ask all the things in the end, because in the middle, if you interrupt, I don't get time and I may get deviated. Okay. So first, starting with the point number one. So I'm going to go point by point, 1, 2, 3, like this. Okay, so this is the way I'm going to go. So, and after the session, I'll be sharing the whiteboards that we generate and all that. Okay, so in the WhatsApp group, so you don't need to worry about it. Our intention. So first, getting started with general instructions on what you can expect from this workshop. Okay, so that's the first topic. So first, let's see that in another 2-3 minutes. Okay, and what you can expect out of this one. Sure. So general expectation. So this is a workshop where you can have maybe I think I can say it like this. So in this workshop, sometimes you come with the mindset like you want to learn everything, but I just wanted to share. Sorry. So I just wanted to say a few things. So you can learn lots of technical things, but in this small period of time, it is not possible for everyone to completely understand what I'm going to do. So my fair judgment on this workshop is I want people to understand the concepts. Suppose when you are trying to see this workshop, so my recommendation is you better try to understand the concepts involved in this CI/CD pipeline approach and all that. And I also recommend people to learn from the whiteboarding that we do. We do lots of whiteboards. So in the whiteboards, you will be able to get a very clear clarity, okay, on what actually we are trying to execute. Basically, the architectures, the pictures, and I'll try to use this whiteboard as much as extensively so that I can deliver my points very clearly with you. Okay, and then you can. Other thing is you can enjoy this session and by making noting down all the points. Okay, so what you have to do is you can enjoy the session, watch the session, and concentrate on the whiteboards and the concepts, and note down your key points and the questions which you want to ask. Okay, so this is what you guys have to do. you guys have to use this time, maybe the QA time after the completion of this workshop. That is, so you guys have to note down your questions. Okay, so you need to note down the questions. So 3 things you have to do. So this is the general expectation from us. Okay, so we expect this from you. Okay, so what we expect from you. So I believe you guys may have got what I am trying to say. Okay, so if you want to get the most out of the session, don't worry about the technical stuff. Okay, some of you may have tried it, some of you may have not tried it in your organization. That's not a big issue. Okay, so focus on the whiteboards. Okay, and concepts that we are trying to explain, and try to note down the questions. Whatever question that you have, you just try to take a plain paper or something, note it down so that we can discuss after some time. Okay, so this is the first thing I want people to expect and understand. Okay, then we can have a smooth another 2.5 hours. I think I'll try to make this more smoother. Okay, so this is it. And I think the next part is I'm going to go to this about us. Okay, so I can't take more time on explaining all these things, but so I'll just try to go one by one. So about us. So in this about us, I'm going to talk about the SloopStash and Inceptors, because we are organizing this workshop. So how we are actually going to, so many things to discuss. So I just wanted to showcase what we are up to and what we've been doing and all that. Okay, so let me first click on my sketch. And so SloopStash is basically like, it is a product-based company. Okay, so if you ask me what is SloopStash, I can say it like, SloopStash is a product company by core. Okay, so we are a product-based startup. So our company has built a product called Sloop Engine. Okay, so I'll try to show the website and all that after some time. So one of the important and interesting features of Sloop Engine is we have built something called as a cloud IDE. And lots of other features are there. This is a primary feature. And we have built web-based terminals and all these kinds of things. Okay. And then the next part of our company is our company is actively involved in lots of open sourcing. Okay, open source contributions. So when you come to SloopStash context, we are involved in lots of open source things. Like, for example, we do lots of things in the GitHub. So if you can check, I'll show all that. In GitHub, you should be able to see lots of starter kits we manage. And then we also do valid contributions to the Docker community. We also have valid contributions to the Vagrant community, which is where we maintain VM images and all that. And our open source contributions are mostly for people who are trying to learn new technology. And if you want to implement it in your organization level, something you want to get started and have a quick hands-on and all that, for that we maintain lots of resources in the internet. Okay, and these are all the primary places. And also we have an extensive knowledge base content. Okay, so the knowledge base means it contains lots of open source articles and all that. And also we do lots of blog posts in SloopStash website, where we generally try to put lots of other things, okay, like technical things and company updates and all that. And then after this, SloopStash is about, it's also about training. We also conduct training programs. So we have 2 levels of training programs. One is the DevOps training program, and the other one is the cloud training program. Okay, so these are all the activities we have been engaged. So the DevOps one and the cloud training programs. And then we also have our consulting part. So that also basically involves in the DevOps and other technology consulting and all that. So I'll also write down that as well. Okay, so consulting. So we do technology-based consulting. Okay. And in terms of InceptTest, how you can relate SloopStash with InceptTest and why the reason why we do these kinds of workshops. So what's our primary agenda and all that. So I'll just come to that also. SloopStash as we are a training partner. Okay, so with InceptTest technology. So InceptTest is mostly about so their main things are they are actually trying to focus on things like training programs mostly. So and then they also try to do some staffing solutions. So mostly they are into this kind of training programs. So they are trying to do so we partner with InceptTest for DevOps and cloud training programs. And InceptTest actually has other streams also. Basically, like InceptTest has streams like it also has data science apart from DevOps. So data science stream is there, and then it also has big data level streams going on. So mostly we focus in DevOps, data science, cloud, and yeah. So these are all the primary area and programming level things as well. Okay. So this is the understanding you can get from about SloopStash. Okay, so when it comes to SloopStash, we also, I also need to introduce myself because I can't put a special schedule for me. So I am John, so that is myself. So a quick background on me is like I started my career on 2010, where I started as a PHP developer in a small startup. Okay, and then I was involved in lots of R&D level things and all that. And then in 2013, I went to Freshworks as a DevOps engineering lead, and then ended up as a specialist of DevOps. And then I came out in 2016. Okay, so and then so my first company's name is The Binary Workshop. Okay, and then by 2017, I think, so 2016, I have resigned my job, and then 2017 we started to work for SloopStash, and SloopStash was not a legal entity at that time. Only by 2018, in the mid of 2018, we found the company. So SloopStash actually the journey started here. So here I started to initialize the initial things of SloopStash, and then now we are actually involved in building products like Sloop Engine from that time, and it's a R&D product actually. So and you can check out all these things in the internet. Okay, so now if you want to know more about us, this is our website. Okay, so in this website you can find the product level things, so links and all that. So basically our motive is we build cloud software products, and we also use this training platform as the place where we share our knowledge. Okay, so whatever we have accumulated in the past 12, 13 years of time journey. So we try to collectively put that in this training program. So when it comes to Sloop Engine is mostly about how to bring your entire workforce and toolkits and things that is required onto the cloud. So you don't need to. So from wherever in the world you are, you can easily work for your company, programming and web access, SSH access management, key management, logging, auditing, activity tracking, and many other things are built into Sloop engine. Okay, so that's our product. And we have a fancy line like if you want to protect your source code from being stolen by the developer team, in that context we work. Okay, so ID is one of the feature which actually tries to solve that issue. And then if you want to check about us, you can see the blogs and all that, as I said. And you can also see the training programs that we have. So training programs like the DevOps, the cloud, and all that. And we also do consulting for companies. And so you can see all those informations in the website. And if you want to know about the way how we share our knowledge, you can see we have a wide range of community articles, okay, knowledge base, where you can, suppose you want to learn how to install Docker and all that. So all these things are mostly open source, okay, so anyone can go read and execute and all that. In fact, we use this for our training programs as well as for our organization-based works, okay. And you can also see from here, you can see the LinkedIn profile of the company. So if you can go to LinkedIn, so this is my LinkedIn profile. If you want to join, or if you want to connect, and if you want to see the work experience of mine and all that, you can come here and see and all that. Okay. And my opinion is don't give connect request now itself. I don't accept now. Maybe after the session is over, you can give. And if you want to know about SloopStash, you can see here. Sorry, I'll just click here. You can follow the SloopStash page for product, whatever updates you want. So mostly here is the place where we post updates and all that in LinkedIn. And we also, as I said, we do open source contributions. So we have a image management level things happening in OCA image management things happening in Docker Hub. And we also have been into Vagrant Cloud, where we maintain our virtual machine images, which we use for our own things, as well as for training and everything. Today also we'll be using one of these virtual machines to build our CI server kind of things. Okay, so this is what SloopStash has been doing. And primarily, if you want to know more about that, you can find it in GitHub generally. In the GitHub, you can find more information about SloopStash. These are all the starter kits which we maintain. Okay, so we've been maintaining for more than 15 plus starter kits, I think, if I'm not wrong. And this is actively maintained by our team, and collaborators are also allowed, okay, if you want to contribute. So we use these starter kits for training as well as our own organization use and all that. Everything is open source. Okay, suppose you wanted to know what we've been doing, you can click and see the commits and all that. So how things are working and all that. Okay. So this is how we maintain, as a small company, we try to maintain so much starter kits to contribute to the open source. Okay, so I think I stop here. So this is the summary of SloopStash and how we are related to Inceptas and all that. Okay, so these are all the primary areas we are working, and I stop here now. I think I can't take more time. So this is how we, so this is the first general instructions, and then now we are into about us, and I also explained about myself. Now we are going to get into the subject, okay? So we're going to talk about first the high-level understanding of software delivery supply chain, okay? So then we can slowly get into what we are going to do, how we are going to do, and all the other stuff. Okay, so first, now we are in the third topic. I have planned to complete the session in 2 hours, but in case if things are getting extended, please forgive for that. Okay, so so high-level understanding of the software delivery chain. Okay. Okay, fine. So here I'm going to correlate our software stack and with the CI/CD workflow. So that is what we are going to actually see here. So from now on, it is very important. So please, I need your attention more. Okay, so I'll try to take some time here and make sure whether everyone understands this. And note down your questions, whatever you have. By the end of the session, we can discuss that. So starting from this, so every organization generally, I mean, I don't speak more, okay? So I'll try to illustratively make things proper, okay? So every organization, sorry. As a software development team, okay? Every organization has a software development team. So let's say this guy is the developer one. Okay, so he's the developer one, or let's say developer one workstation, dev one, and this guy is the dev two, and this guy is the dev three. So if you want me to show it in another way, so this is the dev machines. Okay, so I can put it like small, so it looks like a keyboard. So okay, and so these are all the dev machines, workstations. Okay, so in this dev machines, I mean, generally people try to develop the software. So if you are working in a software company, you have a source code and you develop that source code, mostly your Java app or your Node.js app or whatever apps that you want to develop, you generally develop it here. Okay, so what happens in this development is after people generally develop software source code, they usually push the software source code into a centralized repository like, for example, GitHub. Okay, these days, all of you are familiar with GitHub, so I can only talk about that. So, so basically, like software tools like GitHub, open source, sorry, not open source, it's available in the internet. Okay, so it is there. Okay, so you push the source code changes into this GitHub kind of, sorry, let me, so you push it to services like GitHub. Okay, so this is the GitHub service, let's say, for example. So when you push your code to GitHub generally, what happens in the GitHub or kind of, I mean, some people also use GitHub, I believe, sorry, Bitbucket, and the famous tools like, and even GitLab and all that. So there are many things like this, okay? So whether it is GitHub or Bitbucket or GitLab, so this is what people generally call as the Git repository, okay? So this is the Git repository, and in this Git repository, all the code changes generally enters into this place. Okay, so basically, source code changes that enters into this Git repository. Source code changes. So basically, that operation is what we call as a push operation in Git. Okay, push operation. Okay, so I don't need to write everywhere. So the thing is, now when your code changes are accumulated in a general centric repository like GitHub or Bitbucket repository or something like that, what happens is it tries to, generally people configure something called as a webhook. Okay, a webhook. So when you see the complete software delivery chain, okay, the supply chain, it's a very high level picture. There are so many things involved. I can't put everything here. So you may generally see things like, I mean, in the Git repository, or which is available in the GitHub. So a configuration called webhook is being created. Okay, webhook configuration is created. Okay, so what happens with this webhook configuration is this webhook configuration generally triggers or tries to, or generally it gets integrated with machine or an endpoint called CI server endpoint. Okay, I just used the word endpoint. So it's a CI server endpoint, and that CI server is probably, in our case, it is the Jenkins CI. Square is not done properly. So it's a, let's say it's a Jenkins CI server. Okay, so because in the sessions we told that we're going to use Jenkins CI server, but in general I'm going to put it like let's say CI server for now. Okay, so I don't want to explicitly name anything. So this is what we call as a CI server. CI server. Okay, so what happens in this webhook is any source code changes that happens or changes that comes to from the developers to this Git repository, what happens is you will be able to see some kind of a trigger happening to the CI server. Okay, so basically I can say it like a trigger. Okay, trigger. A trigger happens to the CI server. Okay, once a trigger happens to the CI server has its own task to process. Okay, so for convenience, for now, I'll just copy this thing and put it to the top. Okay, so here. Again, okay. I think now it should be fine. Okay, so when the CI server receives a request, or the way how you've integrated it using the webhook mechanism, the CI server starts a process called a pipeline. Okay, so that is the place where you see the pipeline kind of words come into picture. So people who are totally new to this kind of methodology and all that. So it is basically like the CI/CD pipeline, or the pipeline kind of words, or the workflow pipeline workflow kind of words comes in this context of this place. So mostly this particular thing is going to be, in our case, we are going to use Jenkins for this. Okay, Jenkins is a very standard CI engine. Jenkins is a very standard CI engine, or a CI server, whatever you want to call, you can call. Okay, so when the request comes from a GitHub repository, or as a result of a developer code change push or something, the CI server starts to execute something, or starts to execute something called as a CI/CD process. Okay, so that's the place where we try to inject something like, for example, we have something called as pipeline. Okay, sorry. Pipeline. Okay, pipeline script, or otherwise we call as a pipeline program or anything like that. So you inject this into the CI server, and the CI server runs that pipeline script and does something for you. So that's the primary concept. So whatever you've been trying to build as a CI/CD, this concept is a very commonest concept. You can't say this is a different thing. Suppose there are different things in internet, like Travis CI, you have Circle CI, so many CIs. In Atlassian, you have Bamboo CI, something like that. But it's the flow of this supply chain is basically a constant. It does not mostly change. Okay. So now in this pipeline is the place where you implement your CI/CD workflow. Okay, when I say pipeline, this pipeline is the place where you implement what is called as the CI/CD process, or let's say workflow. Okay, so this is the place where you put all the things and you pump it to the CI server. And when a trigger comes, that pipeline script, if you ask me what kind of script in Jenkins we use a Groovy-based script. Okay, we use a Groovy-based script, whether it is generally called as a declarative pipeline. Okay, so that script is what we generally use, and that is being executed. So that's a very standard process. Okay. Now the next thing is, once the trigger happens here and the build process starts and the CI/CD workflow triggers and it starts to execute, you can also do another thing which is called as delivering the software. Okay, as I said, Jenkins is a CI engine, which means you all may be familiar with this internet term. CI means it is continuous integration. Okay, so the next thing is, after this workflow execution is done, okay, then what can happen is you can release the software, or you can deliver the software, or you can deploy the software. So that's the next step process. Okay, so that is what we generally call as what means CD. Okay, continuous delivery. Okay, so this is, if you ask me, in this step, it is going to be like deployment mostly. Okay, deployment. So that's the step that is going to happen. And now here in this, because the topic here which we are trying to discuss now is called as seamless container-based CI/CD workflow. So we are going to build a container infrastructure, okay, to deploy and run the workloads from Jenkins. I mean, pushing it from the Jenkins CI engine. So here we are going to have an infrastructure. Sorry, we're going to have an infrastructure like, for example, it's an container-based infrastructure. Okay, we're going to have a container-based infrastructure here, not a regular normal server or VM kind of a setup. We are going to play with container infrastructure. So that's the agenda of today's topic. Okay, so I'm just trying to portray it. So in this context, what we are going to do is we are going to bring a tool like, or let's say a cluster like Kubernetes. Okay, we're going to build a cluster like Kubernetes, and in this Kubernetes cluster, we are going to provision our workload or deploy our workload. Okay, so let's say, for example, I just wanted to, let's say, 1 second. Okay, so okay, I think it's not coming beautifully. Okay, we'll just leave it like this. Okay, so this is the part what we call as AWS cloud. Okay, so we're going to have a cloud infrastructure here, a cloud infrastructure, or let me write it in the blue color so to identify. So this is the AWS cloud infrastructure. Okay, so in this AWS cloud infrastructure, we are going to have a Kubernetes cluster. So what you are seeing here, this is a Kubernetes cluster. Okay, Kubernetes cluster. And this Kubernetes cluster is basically a self-managed cluster. Okay, or sorry, I need to use a word called AWS managed cluster. Okay, so there is a service in AWS called as Amazon EKS. Okay, Amazon EKS. EKS is a managed service. Okay, so this is a EKS offers you a Kubernetes cluster, a control plane. I am not going to talk about the Kubernetes architecture here because we can't discuss that full stuff here. Okay, I'll talk about that in another 1 hour. We have lots of books to show and all that. So this is the place where we are going to provision or deploy the workloads. Okay, so our infrastructure is in the AWS cloud. Okay, and it's a cloud-based infrastructure, and we are going to deploy it, inside a Kubernetes cluster. Okay, so this is the Kubernetes cluster where we are going to deploy. I think I can put the name here. Oh, sorry, and put this name here. So Kubernetes that is cluster. Okay, so this is managed by AWS managed. Okay, so that's what we call as EKS service in AWS. So when I say Amazon EKS, some people may not be familiar. So I'm just trying to portray it like this. Okay, so that is this. And so this is the full flow. Okay, so in this flow, how you can divide, I mean, this flow is like, I can say this particular place, what we from, I mean, let's say from the development, okay, from here to say, for example, from starting from here to this place, it is, you can consider it like software development. Okay, you can consider it like software development. And from here to this place, the CI server part, it is the, what to say, CI continuous integration. So I can put it like this up to this. So this is continuous integration part. Okay. And after this, you can say up to this. I mean, screen is not enough. So I just put it here. So this is what we call as, sorry, this is we call as continuous deployment or delivery. So this is how we have to see the supply chain. Okay, continuous delivery, or sometimes in the internet you may find it is continuous deployment. Okay, so it is up to us to decide what we are going to put there. So this is the continuous delivery part, and this is the continuous integration part. Okay, which is what we call as the CI. And then the first part is the software development part. Okay, I'm giving a very high level picture, so you can't expect me to dive deep into all these things. So software development part or software development process or anything. So this is how you can fairly break down this supply chain. Okay, so the full supply chain, the delivery supply chain can be broken like the software development part, continuous integration part. Let me use some highlighters to show that. So the software development part, okay, and the continuous integration part, and the continuous delivery part. So you can break it like anything. Okay, so as I said, this is a generic and a most commonest topic. So you can't expect it to be more precise to a Java stack or a PHP stack or something like that. So it's a common thing. Okay. So now in this, if you ask me, so this is the full flow. Okay. So in this, if you ask me, what are we actually going to deploy? What are we actually going to develop? So that questions you generally need to ask. Okay. So this full CI/CD workflow is specifically designed for, I mean, I need to have a sample stack, right? Because in order to demonstrate things, okay? So we have prepared something called as a CRM stack. We have prepared something called as a CRM software stack. It is something that we used to teach people during the training program. So this is our software stack, okay? CRM software stack. So this CI/CD delivery pipeline and all these things is for development, integration, deployment. All these things are for this CRM software stack. Okay, so that's the point here. Now, what is in this CRM software stack is, this is the part which is something that you have to think of replacement. Okay, so you can think of, let's say, this is a replaceable one in this process. Okay, replaceable stack. For example, let's say in your organization, you may have a very different variety of stack. Okay, you can replace it with that. Now here, the key components that we're going to run here in this stack is It's a Python app. It's a Python app. So that's one service. And then we have a Redis database service. Okay, so, and then we have Nginx web server. Okay, Nginx web server. So these three are the services, okay, that we are going to run here. Okay, Python app, and so for that we are building this CI/CD workflow. Okay, so this stack, if you ask me, I have a Java application and so things in my organization. So is that replaceable? Yes, it is replaceable. You replace this with that stack. That's all. Okay, so that is the way how you have to see through these things. Okay, with your organization specific things, you can replace this stack. Okay, so that's why this is a generic common model. Okay, so you can't say this is very common thing which is implemented only for this setup. So this is how you can see and view into the supply chain. So we have a stack. Okay, we have a stack that is our sample CRM app stack. CRM means customer relationship management. But to make more sense to our training programs, we generally keep very live names for, I mean, it brings more sense instead of saying sample app, sample software stack like that. So we generally don't use that names at all. Okay, so the point is this. Okay, and then if I want to add one more thing into this, means I think I have to say it like, say for example, this CI/CD workflow. Okay, CI/CD workflow can be broken into three major parts. Okay, so I think we'll discuss that in another fresh chart. So I believe you guys were able to see what I am trying to explain here. Okay, in any questions, you guys can note it down for now. Okay, so we'll try to discuss all the questions by the end of the session. Okay, so that is the point. So I believe all of you may have got an idea on what we are about to do after some period of time. Okay, now coming to, I'm just closing this board. So it's now saved, right? Okay. So this is how we can correlate our software stack with the CI/CD workflow. I didn't mention all the tools and things and all that, because if I mention all that, that diagram will be more cluttered. So I didn't mention everything. I've just plainly briefed things here. Okay, fine. So the next step is going to see how do we work out this workflow. Okay, so that is the place where we are going to see the tools in action, and we're going to start with the hands-on. Okay, the fourth topic now I'm in. So let's say, for example, because if I am trying to do this workshop, our belief is like, you also should be able to do if we can provide some recordings or YouTube video or something like that. So if I can only do it, then there is no point in doing this. Okay, so you can try this in your organization and all that. So that's the point what we are trying to do. So please listen carefully. So how are you going to do the workout of this workshop? So what we have prepared is here, if you can see here in the bottom, I'll just take this one. So I'm just now going to zoom in to this part, the CI server part. Okay, so in order to explain the way how we are going to work out this thing. So I'm going to just get into the CI server part and zoom into it and show something that we can understand. Okay, so to do this workflow, we need a proper CI server setup. Okay, so what I'm going to do is I'm going to say it like, for example, I'm going to put it like this. So I'm going to prepare my, So I'm going to prepare my CI server. Okay, CI server. The CI server preparation is going to be like I want to load my tools and my config, because this is the place where all things happen. So I'm going to prepare this CI server. Let's say CI server means it's a, in this context, what I'm going to do is, this is basically going to be a Linux Ubuntu virtual machine. Okay, so I'm going to build, or I've already built all that, so I can't build that in the session time. So Linux Ubuntu virtual machine is what we are going to have. Okay, so in this Linux Ubuntu virtual machine, what are all the tools which we are going to run inside is, we are going to run tools like, for example, let me put it like this. Okay, so 1, 2, 3, 4, 5, 6. I don't know whether we really need to do all that. So the first important things is, if you see in our workout document, so you need to have tools like Git, Docker, Kubernetes client, and Terraform, ngrok, Jenkins, AWS CLI, all these things are required. Okay, so that's what I'm going to mention here. So we need tools like Docker. We need tools like Docker. Okay, we need tools like the Kubernetes client. Okay, because our CI/CD pipeline actually leverages all these things. Okay, and we need to have tools like Git. We need to have tools like Jenkins, and we need to, I also have Terraform, because I can actually put Terraform outside of this, but I am actually putting it inside. But or else I'll just say it like ngrok. I'll explain what is ngrok and all that after some time. So in this CI server, we need these kinds of tools to be done. Okay, and what happens is, when we are actually trying to do this workflow execution, this entire tool sets that you are seeing, the ngrok, the Jenkins, the Git, the Kubernetes, the Docker, and all these things are going to integratively play. So that's what we call as CI/CD workflow. Okay, so our CI/CD workflow, if I want to implement a CI/CD workflow here, so our CI/CD pipeline, okay, our CI/CD pipeline plays with all these things. It requires all these tools. Okay, so CI/CD execution happens in the CI server. And for that, we need all these tools. And Jenkins is the primary engine which we are going to execute our CI/CD pipeline. So we can put it like this. Okay, so this CI/CD pipeline, instead of me putting Jenkins here, I think I can illustrate it like, Jenkins. Okay, the Jenkins is going to get integrated with all these other tools. For now, I just put it like AWS CLI. That is also one tool we need to use. Okay, Jenkins integrates with all these tools here, and for executing this CI/CD pipeline. So if you want me to put more, flow kind of diagram and all that, I'll just try to use this. Say Jenkins, okay, to execute this CI/CD pipeline. Okay, so it uses all these. So this is how things are fairly integrated. Okay, so in this small time, I can't make more better whiteboard presentation. I will rectify my issues after some time. So this is how you can fairly understand what we are going to do. So the primary thing is, you have to know what toolkits we are using. We use Docker here, we use the Kubernetes client, we use the Git, we use the AWS CLI, we use tools like ngrok to accomplish this CI/CD pipeline execution. Okay, so and also one point you have to always remember that why do we do this CI/CD pipeline? The CI/CD pipeline is not just for CI/CD pipeline, it is for CRM software stack we have. Okay, so that part we must always, because that's the workload or the use case. Okay, so we need to always remember this part. For CRM stack, or our, if you want to remember it, your software stack, we have a CI/CD pipeline. Okay, so that's how we need to spell it, and that would be much more better. Okay, so I think this is how we are going to do it. And I'll just now save this one. I want to quickly move to the next one, next thing. Okay, so I'm just saving it. So it should be available here. So this is how we are going to work out. If you want me to show how we have done that, so I'll just show it very properly for you. Okay, so please listen to my screen, watch my screen. So I'm going to up my machine. Okay, the virtual machine which I have prepared. So I'll just try to start it slowly one by one. So only one machine. Okay, so SloopStash into server up. Okay, and so let it start. So we use a tool called Vagrant to power up our virtual machine automation. So generally in training programs, we may need to create more virtual machines. So we can't manually create that. So this is an automated way of building. So this is our CI server. You can, for now, you can consider it like this. It's a Linux Ubuntu virtual machine. Okay, so if you want to see whether the virtual machine is running or not, you can open and check the virtual box. You can see the Ubuntu server running. Okay, so understand it is the virtual machine for now. And then what I'm going to do is I'm going to SSH into this virtual machine. So I'm going to take 4 or 5 SSH sessions. For now, I'm going to show how I am done with how I have done this tool setup inside this virtual machine or the CI server. Okay. So I have now logged in. So there is no GUI and all that. This is a server Ubuntu, not a desktop version. So let me clear the screen. If you want me to, if you can see this workout hands-on of this workflow, you will be able to see this tools like Git, Docker, Kubernetes client, Terraform, ngrok, Jenkins. All these things need to be installed and configured in this way and all that. I'm sure that in the session time, I won't be able to do all these things. If I try to do that, I don't complete the session on time. Okay, now itself we are slightly here and there. Okay, so when I give this document, it's properly documented. You can try it. So I have installed all the tools. Okay, suppose if you want to try this, we have given links to our knowledge-based article. For example, suppose you want to install Docker, you can click here and go to our SloopStash knowledge-based article. In this knowledge-based article, you can see how to install. Okay, so if you want to see how to install Docker, Kubernetes, all the tools we have pointed to the knowledge base. Suppose if you want to search from your own self, you can go here to the resources and go to this knowledge base, and you can search, like, for example, Docker or something like that. So you will get all the Docker's knowledge base articles. It's all open source, openly put available, so you can make use of all these things for your workout and hands-on. Okay, so I have done all these things, installations and configurations. So, and I have also built my Jenkins server. So if I access it now, it will be loading like this. Okay, so Tuto, the username which I'm going to use is called Tuto. It is a cartoon character which we have built for SloopStash mascot. And now this is my Jenkins installation. Okay, so I have in this box, in this CI server box, I have installed tools like Docker. If you can check the version, you see Docker version. we have tools like git install, because all these tools are required for our CI/CD workflow execution, and Kubernetes client, that is client hyphen version, I think. So version hyphen client. So all these things are installed previously. Okay, for your convenience, it was available in the knowledge base. Those links are there, you can install. And we have also installed tunneling software like ngrok. I'll tell the significance of it. So ngrok version, and then what more tools we have, git to docker, and then Terraform. Terraform also is installed here. Hyphen version. Okay. So all these things are there. So we use 1.0.1 Terraform. This is latest is 1.5. Okay. And then we also have installed and configured this AWS CLI tool. Okay. So you can check that AWS version. So AWS CLI also installed and configured. Okay. So now you can see two important services running in the system. One is the Docker engine. Okay. One is the Docker engine that is called Docker runs as a service. Okay. So it is running, and you can also see Jenkins as a service that is running. Okay. So if you want to know where I am getting all these commands, as I've already said, everything is in the knowledge base article. You can go here and click here and see all these things. So the commands are there. Okay. So when you want to try for in your organization. Now, after this, I'm done with the configuration of credentials and all that, because I can't do it parallelly in the session time. Okay, so tools and configurations, the box preparation, CI server preparation, all these things are done for myself. And then I also have a valid Jenkins server running here. Okay, so this is how I have made my CI server box. Okay, I could have actually done that in the AWS cloud itself, but I just want to show it locally and how to. I mean, everyone don't have cloud accounts, so if you want to try, okay, so that's why. Now the next part is like we're going to get into the building of AWS cloud infrastructure. Okay, we're going to get into the, so now as far as, I mean, so far we have seen the general instructions about us, high level understanding of the supply chain, and then how we're going to work out the CI/CD workflow, and then we have seen how we use the CI server as how the CI server is considered as a virtual machine, and how the tools installed and configured. I have shown all that. Okay, in Jenkins also we go with most defaults. I didn't do great configuration. If you ask me, except these two things in Jenkins, I didn't do anything. I have installed a plugin called Blue Ocean, which is mostly used with CI/CD level things to beautiful visualization. And I have installed the standard plugins, created an admin user, and configured the location. So apart from that, I didn't do anything. Like I have just made Jenkins as a sudo or no password. Promptless sudo in the machine. So that's all, and created an API token for the tutor user, which I'm logged in. So these are all the things you can do in the UI. If you have some time, you can check here. All these things are there. Okay, in the Manage Jenkins section, you can find all the options which are there. Now, getting into the fifth step. So building and running the Amazon Elasticsearch. Amazon's Elastic Kubernetes Service Cloud Infrastructure. So we're going to build and run the Kubernetes cluster. So as I said in this diagram, if you see, the first thing that we want is we now have the CI server ready. Okay, and preparing the Git repo is the last part. So that's a very simple thing. And now we need to get this part ready, the cloud part. Okay, so now we are going to get into that part. So let's say the topic is like building AWS cloud infrastructure for Amazon Elastic Kubernetes service. Okay, so now so what we are going to do is, let's say this is our Linux. Sorry, we have our CI server box. So this is our, for now, don't remember it like CI server. So in this context, just it's a Linux machine. Okay, so I have a Linux. I'm sorry. I have a Linux Ubuntu machine. Okay. So in this machine, I've showed already that I have installed a tool like Terraform. So I have installed Terraform. Okay. Terraform is a tool which helps you to, I mean, if I write all that, it takes more time. Okay. So Terraform is a tool which helps you to build and maintain resources on the cloud. So it is a automated infrastructure provisioning tool. So if I write it, time takes. Okay. So I'll just try to put it like this. So in this Linux machine, we have a tool installed called Terraform. Okay. We have Terraform installed. So this is Terraform. Okay. So what we are going to do is in this Linux machine, in this Ubuntu machine, we are going to prepare Terraform by installing, or basically I have already cloned that. So we're going to have something called as HashiCorp's configuration files or HashiCorp's Terraform configuration. So it's a declarative syntax, okay, like pipeline. So what we are going to do here in this box is we are going to fill it with, sorry guys. So sometimes that box creation. Okay, now. So we are going to fill it with the HashiCorp's configuration language. Okay, so that's what otherwise we call as Terraform's configuration. And this is something that we are going to feed into Terraform. Okay, so in my opinion, if you want me to clearly say, this is what we call as HCL. HCL. HCL stands for HashiCorp configuration language. Okay, it is a declarative syntax, and it's not an YAML or JSON. It's something that they have built on their own. Okay, so we provide it to Terraform, and what Terraform actually does is Terraform tries to provision the infrastructure in an automated way. Okay, in the AWS cloud. Okay, so in the AWS cloud, what Terraform is going to do is Terraform is going to prepare this Kubernetes cluster. Sorry. Okay, sometimes this is a part I generally struggle. Okay. Okay, so for now this is enough. Okay, so we can fine. Okay, this is enough. So this is our what Terraform is going to do is it is going to plug and play with AWS cloud. Okay, it is going to plug and play with AWS cloud. In the AWS cloud, what Terraform is going to do is Terraform is going to create the infrastructure required. For example, the main infrastructure that we are trying to build is this Amazon EKS infrastructure. Okay, this is the Amazon EKS infrastructure. In this infrastructure, you have a bunch of master nodes. Okay, you have a bunch of I mean, master nodes we don't manage. It's called control plane, which is managed by the AWS itself. And we have a bunch of worker nodes. Sorry. Okay, so both these things, I mean, first, let me get into this one. So this is what we call as the control plane of Kubernetes. Okay, control plane of, or else let's say K8s control plane. This is created and managed by AWS. So as I said before, this is an AWS managed component. So Kubernetes, sorry, Terraform is going to create this component. Okay, and it is also going to create something called as the worker nodes. Okay, so this is what we call as Kubernetes worker machines or worker nodes, where we run the workloads. So that's how it is going to create. Okay, and this is not just the only important thing. There are so many other things. For example, if you ask me, the module which we have written, I just show it here. So Terraform creates IAM resources. Terraform creates the networking components like the VPC network, the subnets and all that. And then Terraform creates a couple of EC2 level components like NAT server and the EC2 keeper and all that. And Terraform creates ECR repository, image repository, where the CI/CD will put the OCI image from where the Kubernetes cluster downloads the image. So, and the EKS cluster itself, and then it creates the node group and all that. So each and everything you can see, it's all Terraform configuration. It looks very neat and simple. Now, I'm not going to get into this and start explaining that. Okay, so I'm just going to stay away with this. I just want to show that. So this is what we're going to execute. And in this place, if you see here, as I mentioned, it's not just AWS Cloud simply. I want to say the list of services, like, for example, we create Amazon, apart from this EKS cluster, what and all the services and resources created by Terraform means. You can say it like it creates, let's say, for example, the Amazon VPC, which is the networking infrastructure. You can call it like, let's say this is your Amazon VPC components, VPC resources. Okay, and then we also need to have AWS IAM resources. We also create Amazon ECR repositories, which is a replacement for Docker Hub. So here also we create resources. Okay, and here we have a user called Tuto that has to be configured, and we use that one. I mean, sorry, not Tuto. We create instance profiles for EKS. So here also we create some resources, and then we also use EC2, Amazon EC2, to boot the NAT server required for these things. So as I said in the earlier time, you don't need to panic and get confused by all these things, because these are all some kind of an advanced implementation, so automated stuffs. So you can't understand completely in a single stunt because the given time is very small. Okay, but just try to understand what are all the things we are trying to use. So that's the thing that you should be able to take out of this workshop. So the IAM, the Amazon ECR and EC2 resources, VPC, and EKS. So these are the services which we are going to automate with the Terraform. Okay, so I'm not going to talk about how we automate using Terraform. So I'm going to straight away go and start building the cluster. Okay, so I believe this may have given you an understanding. So the HashiCorp configuration language is this. This is how it looks. This is what generally you call as Terraform configuration, or you may call it like HashiCorp configuration language, or we have neatly organized all these things as Terraform modules. If you ask me whether all these things I can get access, yes, of course, everything is in the online. You can see here. Okay, so in the Kubernetes repository, you can find it here in the bottom. Okay, so here I think in the Terraform you can find all that. Okay, so let's go and execute it. I'll save this for now. Okay. So now I'm going to start my workout. So I believe all my configurations are properly saved. So here I have showed all the tools and things that is required. So I'm going to start this infrastructure creation part for the EKS. Okay. So I'm going to clone this one. So already these things are done. So I am not going to run this, downloading the Kubernetes repository from GitHub. All these things are done. So I'm going to start from this one. Okay, creating an SSH key pair. Already, sorry, I need to go to this part. CD. OPD kickstart Kubernetes. Okay. And then I need to create part. Nice. Correct only. So if something is there, I need to overwrite it. And then getting into the Terraform directory. And this is the place where you can see we have the module, Terraform configurations. Okay. And then I'm going to say Terraform init. Okay. And already we have tested this a couple of days back, whether it's properly working or not. So you won't get, so already the Terraform workspace is there. So Terraform workspace list. So we have the prod already selected. So I'm going to select this environment variables, and I'm going to do a plan and apply. Okay, so I'll just click this one. So plan. So plan is basically like a blueprint. Okay, so two operations in Terraform generally we do. One is the plan and the apply operation. So the plan is basically a blueprint. It creates a blueprint on what it is going to affect in the reality. And Terraform's apply is going to create the reality. Okay, so generally when you deal with this automation tools like Terraform, infrastructure automation, there are two terminologies we use. The one is the reality and one is the logical. So this blueprint is highly logical. It shows that what resources Terraform can create on the cloud. And when you apply this blueprint, it will create the resources, and it is in the reality that is the AWS cloud. Okay, so I'm going to now apply this. So to build my EKS infrastructure, so let me first run this one. I have made the plan and now I am applying it. So you should see it should not fail because I have loaded the Terraform with proper AWS credentials. So you should see it should succeed. Okay, and I'm just waiting for this output to happen. As you see here, it is clearly playing that. So it is creating certain ECR repositories and all that. So I'll just go and verify and show what it is trying to do. For example, starting from, let's say, IAM service. Okay, so this is our training account. So I just click on this IAM service. If you can see, this Terraform in the roles section, we create two roles, I think. Okay, so one is the IAM EKS role, and I think there will be something called as IAM EC2 role. Okay, so these two are the roles which is created by Terraform now. Okay, so if you can check here, maybe in the after the completion, after the deletion, I will show you these roles won't be there. Okay, and then if you go to service like the VPC, you will be able to see Terraform creates the VPC resources. Like you see, we have a VPC network created, and then you can see a list of subnets created. So these things were not there before. It's just now created. If you want to check the time, I don't know that it will show the time, but maybe I don't know where to see the time, but it is all created now as a part of this run. For EKS infrastructure, I have created the subnets and route table. You don't need to worry whether you understand this or not. This is all the technical part of building the underlying networking infrastructure for EKS. Okay, and then like that, we also have to verify in the EC2 service. We have created it creates a key pair to log into the nodes and EKS nodes, and then it also creates a instance called a NAT instance. Okay, so that is NAT server that is running, which is to route the outbound traffic from the VPC. So if you can see here, this Terraform run, it's a very pretty quick tool. It just creates things in reality very soon. But if you see here, the EKS cluster creation, actually, it's a time-taking process. Okay, so I'll just show it here in the EKS console. This is the Elastic Kubernetes service in AWS. In this console, you will be able to see the new cluster is, creation is started, but the thing is, its status is still creating. It's not yet available. So it takes 10 minutes of time to provision this control plane. As I said in the diagram, this Kubernetes control plane that is provisioned and managed by AWS. So that takes time. It's a very important component in this Kubernetes. But okay, so if it is down, the cluster won't work properly. And then if you see here, after this creation of this cluster and it gives an endpoint, then in the compute tab, you will see a couple of nodes running here for the Kubernetes. That is what you see here in this orange color. Okay, I'm going to put 2 nodes. And in my node group, I have told I want to put 2 nodes. Okay, so 2 servers will run. So this is how we prepare this cloud infrastructure for running our CI/CD workflow, okay, and delivering the CRM stack software using the workflow, okay. So I think I'll stop now here. This is a time-taking part, okay, so you can take a small break. I think now the time is 6:22. Okay, I think we can restart the session by 6:35, okay, or 6:35 would be fine. So in the meantime, this cluster creation will complete and it will be available. Okay, then we can start playing the next thing, that is the execution of the workflow here. Okay, pipeline workflow. That will take another 10-20 minutes mostly maximum. Okay, so thanks for staying. So I'm putting a small break here. Okay, so let's take a small break and resume by 6:35 p.m. IST. Okay, so in the meantime, let the cluster get Okay, so I'm proceeding with the next steps. So I believe most of you may have got some understanding up to this. So what I have been trying to explain. So this part is what we have now so far built. Okay. So I think in my screen, I believe my screen is sharing, right? Okay. Okay. So you can very clearly see this is a result. This is the result of our Terraform run, and Terraform has created 34 resources on the AWS cloud, which is the reality. And then it outputs few things which is required for us in the next steps. Okay, so I'm just copying these outputs. Okay, this copy, and I'm going to put it somewhere in my editor. Okay. So this output is useful for some reason. So that's why I'm copying this output. So the next step, sorry. Output. So the next step is I just want people to explore what is inside that EKS. So because this session is mostly into CI/CD and Kubernetes, so I just want to show this is how this EKS cluster is built in the AWS. So it's a result of the Terraform execution. And if you click on this EKS cluster, you can see the details of the Kubernetes API server endpoint and these kinds of stuffs. And you can also see the list of Kubernetes resources like the pods, the replica sets that is running. This is an UI-based visualization. So once we create our own resources, you will be able to see here as well. Okay, and here we have created two nodes in the worker nodes according to our diagram. So like this, we are not interested in creating 4 or 5, but we have created 2 worker nodes here. So 1 and 2, and that's the place where we deploy our CRM stack services. And we created a node group here. And the networking part is the VPC resources, the subnet resources, subnets, the security group. All these things are networking infrastructure required for running the EKS. And you may see some tags also, I think we have allocated to this. Okay, so this is how it looks. Okay, now the nodes are ready. So I can go to the next step now. So follow up with me. So the next step here is I'm going to get into, I have now shown how the EKS looks, how to run the Terraform, how I've also explained the Terraform configuration slightly here. I don't have time, so I just showed it. And we are now going to prepare the EKS nodes. Okay, so to run our workloads. Now I just come and take this and put it here. Okay, so I'm going step by step so that you guys can get something out of this at the end of the day. Okay, so listen carefully. This is an important step. Okay. So once you have this Kubernetes cluster built, once you have this Kubernetes cluster built in, should have probably done that. Once you have the EKS cluster built, you will be able to see the control plane that was managed by the AWS. And after that, we have created the worker nodes. Okay, so the worker nodes here. So in this worker nodes, what we need to do is we need to do some kind of a preparation level things. Okay, so let me tell what is that preparation. Okay, we need to, mostly SloopStash, we have a practice. Okay, we don't generally go and store our software source code or anything that we build microservices side. We don't store it in the image, container image. Okay, so we generally download the source code separately. We don't put it because it is an intellectual property. So we need to download the source code into the worker machine. So that's the first step we have to do. Okay, download CRM app source code into the machines. Okay, in the generally in the CI/CD workflow, people try to put the source code with the images, but we should be able to change this practice. So I'm not saying this is 100% right, but this should be automated. Okay, so downloading the source code, what is needed is what first we need to do, and this must be automated. Okay, the download of the source code has to be automated. So if you want to automate this kind of an things within the server or a machine, you can use tools like Chef. Okay, Chef or Ansible will be a great option in this place. Okay, but we didn't have the time this batch, so this time, so we were not able to show how this process also can be automated. So for now, I'm going to do this manually. As of now, I'm going to do it manually. Okay, so downloading the code, and then I'm going to do one more simple step, like creating the required volume directories for running Redis. Okay, so these things these are all the two things that I am actually trying to do within that worker nodes. Okay, so this is one additional extra step. So that could have been automated, but because there is no time factor for us, so we didn't automate that. So creating necessary volume directories for Redis workload. That's why we need to do this. Okay, so these are all the things which we could have avoided it if we have used the proper automation mechanisms, but because there is no big time for us, because we had only 1 week to prepare for this workshop, so we were not able to concentrate into that level. Okay, and then the other part is the source code that we have to download. Okay, source code. Okay, so this is how we can prepare our volumes, or you can call it like storage, and this is our source code. This is also source code. Okay, so, and as I said, this thing we are going to do only on the worker node. So this is a worker node. Okay, this is a worker node. In the worker node only we are going to do this. This is all a set of worker nodes. Okay, Kubernetes worker nodes. These are all the master nodes. Kubernetes master nodes. And that is what we generally call as the control plane in Kubernetes. Okay, so this is how we are going to prepare it. So I need to SSH to these machines and do it. So I'll just run through that step very quickly. So I have just saved this. So this is what we're going to do. Okay, now let me go to the hands-on. This step alone, you guys can think of it like a manual one. Okay, in all this flow. So let me open a couple of SSH sessions to this Ubuntu server VM. Okay. So SSH. I think one SSH is okay, fine, I think. Okay. So in this, I'm going to go to the cd opt kickstart Kubernetes path. Okay, in the CI server now, and then I'm going to SSH to my NAT machine, and through that only I can SSH to the worker nodes that you are seeing here. Okay, and you can take this command from here. These are all SSH commands. Don't worry if you are not well versed with all that. Okay. And I'm going to first SSH to the NAT instance from here. So the NAT instance public IP is like this. So I'm going to take this one and put it here. Okay. So how to SSH to the NAT instance. So NAT instance, it looks like this. Okay. So this is the IP that Terraform has yielded for our NAT instance. So when Terraform's output came, so we copied and saved this IP. So I'm just taking this IP and I'm going to replace it here. So this is my NAT instance. Okay. So now I just copy this and SSH to the NAT instance to properly SSH. So you will be able to see it here. I was able to SSH to my NAT instance in AWS Cloud. And if you want me to show where that is running, it is running in EC2 server. So here, sorry, EC2 service. So you can find it here. So totally 3 instances are running. One is the NAT instance, and a couple of instances are EKS worker nodes. Okay. So EKS internally uses EC2. Then after this, first I want to SSH to the first EC2 node. Okay, so if I want to SSH to the first EC2 node, I need that node's IP and all that. Okay, so how do you get that node IP? You can get it from here. So Elastic Kubernetes Service. So here you can go to the clusters again, click here, and click the compute tab. So you get 2 nodes. So just copy this one and paste it here in the bottom. Okay. And the other one and paste it here in the bottom. So this is the worker 1 and this is the worker 2. Worker 2. Okay. And if you want to SSH, you can blindly say just SSH. You don't need to give the EC2 user and all that. It is already there. Okay, so just I'm going to copy it like this and put it here. It should enter into the SSH of that worker node. Okay, and then I'm going to prepare that node by doing these steps manually. Only 2 steps. Okay, so installing Git and then we have to clone the starter kit, Kubernetes starter kit, and because we want to download the app source code. Okay, and the next step is change that ownership. This is the only manual step that was blocking, so we should have automated this as well, as the time was not there, so we didn't do it. So I'm creating the volume directories required. Redis may run in this node or that node, we don't know. So I'm creating that in all the nodes. So I have now ran all these 5 commands in that one node, and that node is now prepared. Okay. Now that is what is the minimal expectation of the node, and then exiting out of the NAT one. Sorry, worker node 1, and then I'm going to the worker node 2. I'm going to SSH to it and run the same set of commands. Okay, so this is a manual thing, so we have to be patiently seeing that. So should be automated at any cost. Okay, because in production, if you have 50 nodes or 100 nodes, you can't go and do node preparation like this. It's not possible. So that's why learning tools like Chef and Ansible will help you to solve these issues. Okay. So okay. And then I'm cloning the CRM app source code. And final step is creating the required storage directories for Redis. Okay, so persistent data volumes in Kubernetes. I mean, you don't need to know all that. So just okay, I'm just exiting this one. I'm not going to deep dive into Kubernetes and all that, so it's not possible, you know that. So I'm going to, so now we have done the preparation, okay? So preparation of the nodes. So we need to first see how we can manage the Kubernetes from the, how to manage the control plane of the Kubernetes, okay? For example, if you want to use this control plane, what you need is you need this kubectl tool to be configured properly. Okay, so to do this kubectl configuration, we have a step before this one. After the Terraform apply, I should have actually come here. So let me just copy this command and configure the Kubernetes client so that I can execute the management commands in the Kubernetes. So management commands in the Kubernetes to show the resources in the command itself. Okay, so let me take this. I mean, we'll just leave this window for now. I'll take another SSH, okay, because we need more SSH to the machine. SloopStash, we're going to server and SSH. Okay. And here I'm going to run this command. So that will configure my Kubernetes client. Okay, using, so this is an AWS CLI which talks to EKS and tries to configure this one. Because as I said, if you want to manage that EKS control plane, what I'm talking here is, if you want to manage this EKS control plane, I think I'll just pictorially do it. Maybe that is more better. Okay, just a few minutes. So you have the control plane here. Okay, so this control plane is what you're going to manage. Okay, so if you want to manage this control plane, you need the Kubernetes client to be set up out of your, I mean, I'm setting up it in my virtual machine box. So what you can actually do is you can have your, let's say your laptop machine or anything, okay, or any machine. In that machine, okay, what we need to do is we need to set up this Kubernetes client, that is otherwise called as kubectl. Okay, so this kubectl reads a configuration file. Okay? It reads a configuration file. This configuration file was created by this AWS EKS command, which you can see here clearly. I've run that. Okay, so this is how we are configuring this. And now using this kubectl, we can talk to this one. Okay, why it's curved still. We can talk to this control plane. And using this thing, we can control the entire cluster. So this is a very basic thing. And suppose, I think I should have actually shown this thing. So in the DevOps sessions, generally, we try to paint this architecture of Kubernetes. So this is also in hand sketching like that. And I mean, it has lots of parts in that. Okay, this is a generic Kubernetes architecture where we go and show so many components involved and all that. Now it's not the time to talk, and we also show how to create the Kubernetes cluster in a bare metal and all these kinds of things. So it is a very complex part, and that part is what automated by AWS in EKS. Okay, so that is what this control plane is. So that's how we control it. So let me close this one and come back to the same place. Okay, now this is done, and I'm going to see whether I can run some commands and get some output. Okay, then I can go to the CI/CD part. Okay, so let me go down. So we have a command like, let's say kubectl. This command, I'm just going to plainly run it. and see if I can get some response. Okay. So you see some response is coming. It was able to pick something. We haven't created so many resources. So it just shows few things that is available. So response is coming means the kubectl client was able to talk to the Amazon EKS cluster available in the cloud. Okay, that's how this is now configured. So this is my CI server box. Okay, so this setup is done. So actually, we are now done with this verification and preparation of the cluster. Okay, now the next part is architecture of container-based CI/CD workflow. Okay, I don't take more time, so I just try to take another 15 minutes. This is the important part because we've been doing all these things for this. Okay, so architecture of container-based CI/CD workflow. So let me come back here and hold understand. Okay. So first, I'll explain this architecture of the CI/CD workflow, and I'll make it more simple. Okay, this time, so not complicating it. So let me put it like I can say it like. Okay, I think this is also fine. So okay, maybe sorry. Oh, I think this is more. So let's say this is our pipeline. Okay, our CI/CD pipeline. Okay, we can divide the CI/CD pipeline as we have already seen. We can divide it like the build, test, and deploy. That's a usual generic DevOps way of defining a pipeline. Okay, so this step usually people call it like the build phase. Okay, build phase, and then this step generally is called the test phase, and we have the other step called as deploy phase. Okay, so generally in our Jenkins sessions we do it like that. So so that's why I'm doing it like this. In this, you can see this the build and the test up to this. Okay, up to this, you can consider it like the CI part. Okay, consider it like the CI part. And the next phase, the deploy phase, is like you can consider it like CD part. So this is how we naturally split this pipeline. Okay, so this is CI part and this is the CD part. So this is how we split it. And I just want to portray what kind of tools we use, because when I say the pipeline which we have built for demonstration has two parts. Okay, CI part, CI part, CI part, CD part, CD part, CD part. So there are 3 steps which I have allocated in there. This is our pipeline script or declarative syntax oriented script. So this is Groovy based declarative pipeline. So this pipeline script is composed of stages. Okay, so 1, 2, 3, 4, 5, 6, 7 stages. In the first stage, I am trying to download the sources which is required, like the Docker sources to build the Docker files, and Kubernetes sources, which is to configure the Kubernetes client, run the templates later on. And then I can't explain fully, forgive me for that. Okay, so then configuring the Kubernetes client, because that AWS CLI command has to talk to using Jenkins, we need to talk to the EKS cluster, and then we need to build the Docker images for the CRM stack, because containerization begins with OCI image creation generally, as it is a CI/CD, containerized CI/CD pipeline. So OCI images are the important thing. For app, I need to create an image. For Redis, I need to create an image. And then push the images to the ECR repository, which is OCI image repository. And then I need to apply the Kubernetes labels and run Kubernetes commands to complete this workflow. Okay, so you can't completely understand it in a single run, but these are all the phases of my pipeline. Okay, totally 1, 2, 3, 4, 5, 6, 7 phases we have designed. Okay, so CI phases and CD phases. So in the first phase, okay, so I'm going to break it like tool by tool. So in the first phase, you have the first step that requires Git. Okay, and the second step generally requires Kubernetes client. Okay, Kubernetes client, and or else I can put it like this if you want. So the first step, it needs Git. Okay, second, you need Kubernetes client. Okay, third phase, you need Docker. This is how Docker is integrated. So you need Docker, and the fourth phase, you need to again have Docker to push this thing. You need AWS CLI also. The fourth phase, AWS CLI. Okay, AWS CLI. And then in the fifth phase, the CD phase, you find the kubectl commands are running again. So you see, repetitively, we use these tools like the AWS CLI tools, the Kubernetes client tools, and all these things regularly in this pipeline. So if you ask me what are all the list of tools being used in this throughout CI/CD process, we use these tools: the Git, the Kubernetes client, the Docker, and the AWS. So collectively, we are using it in this entire pipeline. Okay, so this is how we are using these tools. Now, there will be a question coming that people ask that how this tool is, I mean, we are now running the Jenkins in local machine. So how are we going to execute this CI/CD pipeline? Because in the GitHub, we have repositories, and how the trigger can happen, how local thing can be executed from the internet, how that process is going to happen. So for that, we use a tool called ngrok. Okay, so this is the place where we come to a tool like ngrok, which is a very handy tool for development. Okay, of these kinds of pipeline and testing it. Okay, so you can say that what I'm going to do is I'm going to run this ngrok tool. Okay, I'm going to run this ngrok tool in my Linux machine. So all these things are going to be there. What this ngrok tool is going to do is, when any commit comes from GitHub, okay, sorry, when any commit comes from GitHub, it's a tunneling software. Okay, so let's say this is GitHub. Okay, so GitHub, where I have my CRM app repository, which I'll show after some time. Okay, so when the developer commits changes or pushes changes to this repository, okay, so when a developer, okay, let's say push changes, and a developer push code changes to GitHub. Okay, so what happens is GitHub will fire a webhook. Okay, GitHub will fire a webhook. So this webhook firing is basically okay. It's okay, fine. So this webhook firing is something which is a mechanism built into GitHub. Okay, webhook firing. Sorry, webhook trigger. So what happens is ngrok is a service that runs in the internet. Okay, ngrok is a service that runs in the internet, and what happens is the request that comes to the ngrok service in the internet. Now, when I say $ngrok, it may mean like ngrok is running in the machine. So it is an ngrok service in the internet. Okay, we need to think of it like that. So GitHub triggers ngrok. Okay, ngrok is a service that runs exactly like GitHub in an internet. This software is called as, if you ask me the definition, this is an HTTP tunnel, okay, or tunneling program, tunneling software. Okay, so I don't want to explain all these things, may complicate stuff. So what happens is once the webhook trigger goes to ngrok, because we don't have the Jenkins hosted in the internet. If it is hosted in the internet, you don't need this ngrok. Okay. The problem is the CI/CD pipeline which I'm trying to build is not hosted in AWS cloud or in the internet. It is hosted locally. That is the problem. Okay, so the CI/CD pipeline which we are trying to execute here, this is something which we are going to do locally. Okay, sorry. This is running local. And that's why we need a tunneling programmer software. Okay, so to forward that request properly to this local Jenkins. So that's why we use ngrok. Okay, local Jenkins server. Okay, fine. Now, ngrok is an internet service. So what we have done is in our VM, what we have done is we have installed the tool called ngrok command line. Okay, so $. Okay, so this command receives that hook, okay, which you are triggering from the GitHub. Okay, so this ngrok which is running, this is also locally running. It will receive the webhook trigger from the internet service that is called ngrok internet service. So through that, this pipeline will be executed. So this is how this pipeline connectivity is happening. Okay, so because if I try to run Jenkins in the cloud, that sometimes people can't try to work out that flow if they don't have a cloud account. At least they can see build part at least. Okay, if it is possible. Okay, so this is how we are going to execute the pipeline. So I have just tried to brief the tools. I didn't go in depth, but I am just trying to brief the tools here, what we've been using here. The Git, the kubectl, the Docker, and we have the AWS CLI command, and also we have the ngrok tool. So, okay, so now I believe all of you may get an idea on why we are doing all these things. Okay, and then after this CI/CD pipeline deployment is done, we take it to, it will deploy it to EKS. Sorry. Will deploy it to. Okay, so into the Elastic Kubernetes service, things will be deployed. I'm not still. Okay, I just put very slowly. Okay. Okay, so this is our EKS cluster. Okay, so here it will be deployed. The service CRM stack will be deployed. So this is Amazon EKS. So this is how we are building this delivery pipeline. Okay, well, so I believe all of you can pictorially understand what I am trying to do. So I believe this gives you a clear conceptual idea. Whether you can do it technically or not, that's a different story. You don't need to worry about that. Okay, so now I'm going to go and execute this one. I think I am done with all my points and stuff and all that. Okay, so let me go and execute it because time is clicking on. Okay, so I have to do this properly. So now I'm going to configure this in the Jenkins. So as a part, first I'm going to create a folder in Jenkins called CRM. Okay, so this is my Jenkins. In the Jenkins, I'm going to, sorry, it's logged out. So I'm going to log in and create something called as a folder first. Okay, CRM folder. That's a type of software or software stack. And once the folder is created, I mean, you just give a display name and all that. No need to do everything. And inside the CRM, you have to follow the document. In the document, we create a project called containerized pipeline. So this is the crucial phase of what we've been doing so far. So I'm going to create a job inside that. So giving containerized pipeline and select the pipeline type of project and save it. So you will be able to see it like this. In that, what I need to do is I need to configure this containerized pipeline project in Jenkins. Okay, so here we have the pipeline script. Okay, so and also you can see it here. So this is the pipeline script. In this pipeline script, two things we have to change. One is the worker node 1's IP, and two is this worker node 2's IP. Okay, so these two things we have to change. So what I'm going to do is I'm going to go here and take this worker node's private DNS name and fill it here. 1, and this is the 2. Okay, and fill it here. Okay, and that's all. Okay, and then I'm going to copy this pipeline and paste it inside my Jenkins. Okay, in the bottom you will see a place called pipeline. There you find that text area. So you just put it here. Okay, so here I have given the environment name as prod, and I think I have given the account number, and I think I should give this environment name as staging if I'm not wrong. I think I should give it to staging. So I forgot that. So staging environment of CRM stack. Okay, so just to give some flavor here. So and then what I need to do is I need to select how the build in this pipeline can be triggered. So let me click that. So here it asks for an authentication token. If you see in the document in the next phase levels, you can find that we have the secret token here. So this is what I mean. It says not secret. It's not saying secret. I need to put this in the pipeline authentication token. Okay. So in terms of configuring the pipeline in the Jenkins side is over. Okay. You need to give the secret token. You need to add the pipeline script properly, and then you need to have proper name and all that, and then you just need to save it. That's all. Okay. So it is now saved. And you can use this Blue Ocean, which is a newly developed, not newly, it was there for a long time. If I open this Blue Ocean, you will be able to see the stage level execution very properly. This is a very fantastic user interface where you can see. So far, this pipeline hasn't executed. So in order to execute the pipeline, I need to configure the webhook, which I've been talking about for a very long time. Okay, so first, let me run this ngrok tunnel and then let's go and create this webhook from the GitHub. Okay, then I think it is over. We will complete the session. It will be done. Okay, so we can see how that is executing. So to run the ngrok, I'm going to use another SSH. So sudo script / vagrant SloopStash Ubuntu server SSH and then I'm going to run this ngrok tunnel. So if I want to run this ngrok, I mean, with the proper configuration, I need something called as auth token. I believe auth token is already there. So I think I have to run this one. If not wrong, it should run. Okay. So you can see it is starting. Okay, so this is the tunnel which we are establishing to ngrok, service in the internet. Okay, and this is my URL. It has given to me customly. So I'm going to copy this URL. Okay, you may see it like so many steps, but these are all, if you follow one by one step, it will be very clear for you. So this is my ngrok URL. Okay, which is available from the internet. Now the next simple step is to go and configure the CRM app. Okay, so we have the CRM app available here. Okay, in the SloopStash, if you can see a repository called Flask, which is the app which we have written, CRM application. It's a tiny, well-written app. Okay, so I'm going to click this one and I'm going to fork it to my specific user, John. Okay, so clicking the fork and I'm going to say it like, rename it like CRM app. Okay, and I'm going to create this fork. So it will be under my account. So it's now under my account. Okay, so it's available. So from SloopStash, I have forked it. And I'm going to now configure the webhook for my account, for this repository. So if you go to the settings and go to the webhooks, you will be able to see the add webhook. And if you click on that, it will ask you for this authentication code. Let me ask that on my phone. So it is 745. Okay. So it opens up a webhook UI like this. So now I'll just tell what I'm trying to do. I'm trying to do this part, the webhook configuration part in the GitHub, and have ran the ngrok, and then we're going to execute the pipeline from here. Okay, so that's what I'm doing. If you slowly sit and see all the whiteboards, you will be able to definitely understand that. And now let me go to the webhook. And the payload URL it asks. So you can find in the book, it is clearly given the payload URL. I'm just going to copy this payload URL. And I'm going to put it in the subline. So if you see here, this asks two important credentials. One is the API token, and other is the ngrok URL. Okay, so ngrok URL is here. So this one, so you can copy and paste it here. Okay, and the other one is the API token. So if you ask me where I can get the API token and all that, I think you can create one. Okay, so I already created it, but suppose if you want me to show how to do that, I just create it again. Okay, so sorry, I think where administration. So inside you go here to the tuto in the configure. And I already created a token called GitHub. Now I just create another token. I think GitHub2 like that and generate. You see a token created. So just copy this token. Only once it will be visible, and you just put it here. Okay. So I copied or not. So control copy. Okay. And I'm putting it here. Okay, so tuto is a username in the Jenkins server. This is the API token, and this is the ngrok URL. Once GitHub triggers hits the ngrok URL, ngrok tunnel which we are running here will receive the hook. See, it's not had received anything. Now, the moment I take this URL and copy it, and if I put it in my GitHub account, the payload, and I just want to configure it for the push event. I don't want anything. So once the webhook is added itself, okay, you should see something happening. So it should show it like, it should automatically trigger it. It should automatically trigger that. If you click that. Okay. You see, one trigger has happened. One trigger has happened, and immediately if you go to ngrok, you may see that one request has come to ngrok. See, for my containerized pipeline project. So ngrok received it. So from the internet, this is how you can, suppose if you are a developer and you are building CI/CD pipelines, first you need to know how to set up the dev environment for it. And this is how you can beautifully do it with this tunneling program. Okay. And then you see here in the Jenkins, the CI/CD process has started for my stack, my pipeline, containerized pipeline. So one run is started. So you see this is running. I just click it here. And you are able to see that you are able to see the Docker images and all these things are happening. Okay, so I think the images are getting created. So the first step is downloading the source code from GitHub. So the Docker starter kit, Kubernetes templates and all that. And then the next step is configuring the command line for Jenkins. I mean, the EKS command line for Jenkins. So that step. And the third step is building the Docker images. So you can see we are building the container images using Docker. So this is the Docker command line. So it is running that. And I believe they are all taking from the cached ones. So effectively, because we did it yesterday or a couple of days back. And now you can see this is being pushed into AWS ECR. That is the replacement for Docker of this cloud repository. Okay, for OCI images. I think I should have shown that. In the EKS service itself, you can have a related link here. If you click here and open it, you should be able to see the Amazon ECR service where you can have the Docker images and all. So you see, I have created an app image and a Redis image, which is a part of our CRM stack. And I think the push is happening in the CI/CD realm. So we need to wait for that. So that is still executing and pushing. So it takes some time. So let it push. And so it is pushing. So one image is pushed and the other one is happening. So let's wait for some time. Okay, so okay, I think that is also pushed, it seems. Okay, it is going now to the fourth phase, or not the fourth phase. 1, 2, 3, 4, 5. Okay, fifth phase. It keeps on refreshing as it moves within the stages. Now we are in provisioning Kubernetes persistent volume. So that phase is completed. So we create volumes in the Kubernetes cluster. And then now we are in the creation of Kubernetes API resources. So we have fairly we have divided it like the 4 CI steps and 3 CD steps. Okay, so I think now the pipeline is complete. Okay, so you can now see how that has neatly spanned out. Okay, so this is the beauty of this Blue Ocean UI. You can see things in stages. If you want to explore the same thing in the Jenkins old UI, it won't be more appealing. Here you can see each and every command's execution, how what are all the resources you created, separating the commands and the outputs and properly. So I believe the app is deployed and Redis service is also deployed in the Kubernetes and all that. So we don't have a testing stage, as I think I should have told that. In the testing phase, I didn't do anything. So we are just building the OCI images and pushing it to the ECR repository and deploying it. That's all. Okay, so that's what we are doing. Now, if you can see here, this is completed. So what you can expect here after this pipeline execution is you will see this is deployed in the EKS cluster, the CRM stack. Now, if you want me to show how that is deployed, you can see Kubernetes resources created, like let's say maybe you can find it like pods and all these things. So you can see app, all these things are based on the specific thing. Okay, so a CRM stack. Okay, and as a result of that, you will be able to see a load balancer created in AWS. Okay, EC2 service. So that load balancer is created from the EKS cluster. And what I'm going to do is I'm going to select this load balancer and get that endpoint. Okay. So click that load balancer. It's a classic load balancer, which is a retiring one. And copy this endpoint. I'm copying this one. And I'm putting it here. So I just want to hit http:// and we know how to access this app. So putting the endpoint and hitting it here, you should be able to see the app opening. Okay, so now we have what we have constructed. So suppose if you want to know whether this is properly saving something, I just want to say save something so that you can understand how Redis is also deployed. Let's say support at SloopStash.com and something like that. You see it is saving properly. So which means the provisioning has happened properly. Now, if you want me to show how to verify it in the control plane level, we have given the commands here. Okay. So in the box here, if you see, I've already shown that somewhere. Here. So I'm going to show how the resources are provisioned for the CRM staging environment. You can see it like this. Okay, so using the simple kubectl commands. Okay, config maps I've created Redis stateful set deployment for app and pods, running Redis pods, app pods, and services are created, and external load balancer is provisioned. So all these are Kubernetes stuff. Who created it? CI/CD pipeline created it. Okay, from this pipeline, we are executing all these things. And as a result of that, it is affecting the Kubernetes cluster. So this is how, I think I have taken more time. This is how you create and deliver a containerized pipeline or containerized CI/CD pipeline. Okay, so I think I have taken much more time, maybe in more than 10-15 minutes extra. Okay, so I think I'm done here. If you want me to show the deletion part of this, wipeout part of this entire cluster and all that, I'll show it at the end. But before that, we need to have a QA time. So I think my session is done. So how many of you have questions? This is the seamless container CI/CD pipeline execution. Okay, so I didn't show any code push and pull and all that. Okay, fine. And one more thing, 1 second, guys, I want to do some small announcement, which is from our side. So these things that we have showed in this couple of hours are too much for people because it's a very huge execution. Okay, so generally in the DevOps sessions, we take all these things in the detail. Okay, for example, if you check out our course content, this is the course content for our next batch. So it is the full stack DevOps engineer, including AWS and Azure, where you see all these tools. Okay, so in detail, we will try to teach people and all that. Ours is once in a year, we generally conduct a training program that is for 7 to 8 months, 9 months, usually it takes. So we have mini projects in Kubernetes and major projects in Kubernetes, AWS Cloud, Azure Cloud, Terraform, Kafka, and all that. So this is the place where we nurture people. If you want to see this full end-to-end implementation of things, these things can be done in the project level stuff and all that. So this is how we actually train people, and this is one just small announcement which I wanted to make. Okay, if you want to see the full course content of our DevOps training program, you can get it from this course view course content segment. You can see it here. So the full content will be around 70 pages or something. So you can see each and every single step of what we are trying to do. Okay, so this is what I wanted to complete with an announcement. So I believe I'm done with my session. In case if you guys want to ask anything, you can ask. Unmute and ask the questions.
Hey,
anyone want to unmute and ask questions?
Hello, John. Can you hear me?
Yeah.
Hey, Vinod here.
Yes, Vinod.
First of all, thank you very much for this wonderful session, John. It was really informative and you have covered a lot within quick time. So almost it's like kind of dictionary for a developer like me who doesn't have any much idea on the DevOps side. So thank you for that. And so one question I have, like you have done some manual updates, which you told like you can use Ansible or Chef to do that, correct? Again,
Yes.
in that case, that again has to be invoked using Jenkins, or like how Ansible
that has to be invoked using Jenkins. So basically it will come like a step in between here. But actually what happened is the plan of this workshop, we actually had only 7 days to prepare.
Got it.
So in that time, we were not able to put together everything. So we thought actually at least we do that manually. We can integrate. We actually in the DevOps training generally we integrate and show people how to use Jenkins with Ansible and these kinds of tools. So that's the nature of our training. So lack of time, we didn't do that. That also could have been automated. So it's a very cheap thing to do it.
So that also should go via Jenkins only.
Yes.
Okay.
It will. So basically, the idea is very simple. In Jenkins is not doing everything, the heavy lifting. Jenkins is a tool, okay, so which integrates all these tools to do something. So that's what we call as a workflow and all that. Jenkins is a CI server or a tool which integrates with, because if you see Docker, Kubernetes, Git, or any tool in the DevOps world, you see they just specializes in that particular area. Jenkins is a place where you integrate things.
Orchestrated. Okay. So similar way, like how we use Kubernetes client here. So in case I need to deploy some Lambda or I need to install something in the EC2, then like the relevant clients or supporting packages should be installed in the Jenkins.
Yeah. But in my opinion, if you see here, what I was trying to demonstrate it, I didn't bring the infrastructure building part. Meaning, when I built this EKS infrastructure using Terraform, I didn't trigger that using Jenkins because that is not a wise decision to do. Building the networking infrastructure and cloud infrastructure, always we have to take it out of the CI. That is a wise decision. Okay, infrastructure confidence. If you keep on triggering for every single code push, and it may corrupt your infrastructure. So that part alone, we wisely take it outside. That's how we actually implemented in our company. And other parts like the next things, the CI/CD part. So the app deployment, that, and the testing part. Testing we didn't do. All these things are in the Jenkins. Image building part and all that.
Yeah, Terraform script execution would be only one time, right? That you don't require.
That is why. Yeah, that is why I made it outside.
Yeah,
I didn't put that in the CA.
Yeah, right.
Yeah, John. Thanks. That's a question I had, and maybe like one big question. So I have seen like my DevOps team. They are using CloudFormation kind of things and all. Is that something very similar to Terraform, or that is?
Yes, CloudFormation is a rival for Terraform. It is a cloud native thing. So Terraform is basically an open source tool. So you can plug and play Terraform with any cloud service provider in a single run. We use Terraform for Sloop engine infrastructure provisioning. So irrespective of any cloud that you use, you can use Terraform. But CloudFormation is specific to AWS. It is a kind of an a native AWS service. For example, you can't use it with other things. Okay, I think somewhere it comes here. Okay, so that's a comparison. It's a native implementation, and we can call it like a proprietary thing or something like that.
Perfect.
Okay.
So, thank you.
Yeah, Terraform is a CLI equivalent of AWS infrastructure creation, right?
Actually, okay. So Terraform means Terraform. Okay, one second. I'll just open a whiteboard which we recently did for that. Sorry for that. Terraform has different offerings. Okay, so if you ask me, Terraform is just a CLI. I don't say Terraform is just a CLI. The CLI in the Terraform, what we have used is the Terraform CLI here, and that is a one offering. Terraform also offers enterprise. Terraform also offers Terraform Cloud, where you can store the state and all that. But of course, the CLI is an open source thing, and that's where we call the command called Terraform and all that. So that is how that is Terraform. Okay, we have options. Terraform Enterprise, Terraform Cloud is there. Okay.
Yeah, I mean, creation of AWS resources using CLI commands with the help of Terraform. That's what I meant by.
Yes, true.
Okay. Got it.
Okay, true.
Yeah. Okay, yeah, thanks a lot.
Mm-hmm. Any questions people have? I'm ready to answer. You can ask me anything because the full flow. So don't hesitate to ask.
Hi, John. This is Bala. So thanks for the wonderful session. I have some small doubt actually. So because due to the timelines, you're unable to show that code push and all, right? In Jenkins, where we have to enable that option. So as soon as we do the code push, how it will the build is triggered or something, right? Can you show that part? That would be helpful actually.
Yeah. So I have used this ngrok, okay, as a tunneling program and all that, but usually this is not the way how you construct it. When Jenkins server is running in the internet, okay, now it is local, so I used a tunneling mechanism to trigger it. So if you go to GitHub, in general, GitHub or Bitbucket or anything that you use, these modern days version control system, I mean repository management tools, all of them have this webhook mechanism. So in the webhooks, you generally go and give the Jenkins URL. So this is basically a Jenkins server's URL. That's all. Okay. So instead of giving the ngrok URL here, so what I have done here is I have pasted the ngrok URL. Instead of that, you need to give the Jenkins URL here. Okay, once you give the Jenkins URL and save this webhook, okay, and then in the GitHub specifically, you have for every code push that is coming to this repository, it will fire. Suppose if you want to select for many actions, for example, you want to select for branch creation and deletion or branch creation, or if you want to trigger this webhook for releases, if you want to trigger it for, there are so many actions GitHub provides, even Bitbucket also provides. Okay, so in that scenario, you just select these actions and save it. When that particular action or an event happens in GitHub, now we have just seen with just the push event. I mean, I think I didn't do any push actually. Okay, what I did is once I created the webhook, it will do a default run of the webhook. So this webhook was fired. Okay, it went to the ngrok, and ngrok received this webhook, and it triggered the local Jenkins, and Jenkins started this CRM pipeline execution. That's all. But if you want to do it in another, if you want me to show it separately, now you can go to the CRM app. This is my source code repository. I'll just go and do a small edit here. Okay, so I'll just do one. Let's say I'm going to add a README file. Okay, and commit the changes. Committing README. Okay, so I have now just made a commit here. So once the commit is done, what usually you can expect in the webhook is you can see another webhook trigger may have fired. You see number 2 for a push event, because I have done some file creation in the repository by just using the UI. And then as a result of that, you see another pipeline execution starts. So close this, you see. It's the way how this webhook mechanism works.
Yeah, John, got it. Yeah.
Okay.
John, if possible, can you share that recording session? Can we able
Yeah,
to perform
everything will be
similar exercise with the GitHub URL, right?
Yeah. We'll give all these materials, the whatever I have done in the whiteboards and whatever I have done with the hands-on. So I've done the documentation properly. So we have done it properly. So you can go and execute it when you are free. Okay. So and also we'll publish this as a post and we'll publish it in the YouTube video and all that.
Okay. Sure, John. Yeah.
So and we'll post that in the group in another 3 or 4 days, at least in 1 or 2 days.
Hi, John. I'm Bhuvna here.
Yes.
Thanks a lot for the wonderful session. Just here, the webhook, which we are configuring in the GitHub, that is a mandatory part, or that is how the next step, like Jenkins, that triggers a build. So, is that a mandatory part?
Now, generally, you can automate this thing also. If you know how to use GitHub's API, you can script it and run creation of the webhooks after you create the repository. That's possible. It's not undoable, but
Okay.
usually, if in a company, in a very well-grown product company or anything like that, you see people have, I mean, in a small startups, first I'm saying, so you have 20, 35, 20, 25 repositories where you can click and create this webhook. Because this URL is not going to change a lot. Okay, when I give so Jenkins URL is going to be the standard URL. But in case if you have hundreds of repositories and want to, suppose let's say you have 100 microservices and you want to trigger the Jenkins build for anything that comes to all these 100 repositories, then you can't manually do it. So you have to use the GitHub's API, GitHub gives API, and to create this one. Suppose if you ask me in the Terraform's way, Terraform also has this mechanism of integrating with small services like this, but I don't recommend it. You can script it using the GitHub API. So this details will be filled.
Okay. Yeah, thank you. Got you.
Any questions? I think you asked mandatory or not. Is that your questions? I mean, some person asked.
Yes.
Okay, this is not a mandatory one.
Okay.
Okay, if that is your question, I mean, if you want to automate it, that's what I've been speaking. This is not a mandatory one. You don't need to put webhook URL for all the repositories. It is not needed. Only for the repositories which you want, which involves in the CI/CD pipelining workflow, you may need this. Otherwise, particularly to be more precise, you need it only for the app repositories. Let's say in our case, I said that's why I've given the name as CRM app.
Okay.
For other repositories, if you ask me, I can show the Kubernetes and other things and all. There is no webhook and all that.
Okay. If it is involved in CI/CD, then definitely webhook.
Yeah, because for app, because sometime back I showed, right, the CI/CD whole stuff is going to be for this app stack, software stack. So if there is no software stack or nothing like that we are going to use, and I don't think the CI/CD is going to make any sense here. Correct, man? That's fine.
Yes. Fine.
Okay.
That is what my query. Yeah, thank you.
Okay. So if you guys have any questions, you can ask. Utilize this time for question and answers. By, I think, next Saturday, we are kickstarting our new DevOps batch. That's another time I am announcing this. This batch is getting started next Saturday. Okay. So if you are interested, you can contact Sujan or Basit from Inceptus or SloopStash. Okay, in case of no questions, I can delete the resources, so that also I can show. Okay, so I think first I'll start with the Kubernetes, because I also want to show this. We also want to show this completion of that. So here you can see how to delete the CRM stack level resources which we use to run CRM, app and Redis workloads in control plane. The command is fairly very simple. Okay, so kubectl delete namespace CRM STG, all the resources will be deleted. I mean, if you can see here, this all the resources we created in Kubernetes, you can delete it just like this one command. Okay, because all these things are namespace, so I'm deleting it. And once this namespace is deleted, the pods, the services, replica sets, deployments, stateful set, config maps, all those things will be deleted. Okay, so I am waiting for that. And in the EC2 realm, you can also see the load balancer which it created. That also shall be deleted. Now you see it is deleted already. No load balancers. So in a matter of command, all these things are, so it's now done. So if you run this previous command again, listing the summary, you don't find anything. So it's empty. So you don't get this full output. It's empty. And after this, I can also delete my Terraform workspace. Terraform resources. If I want to shut down this whole cluster and destroy it completely, I can do that by using this single Terraform command. So I'll just run that as well. I believe people have no questions related to anything, so I'm going to destroy it. So it will be gone. Okay. So I'm going to the first tab and putting this command and running it. That's all. Okay. All the resources we created totally, I think 34 resources. 34 resources will be deleted. So neatly wrapping it up. Okay, so it shows the blueprint on what is going to be deleted. So everything. So just say yes, we'll start deleting. Okay, so I believe the deletion part will be a bit faster than the creation part. Okay. So fine, I think it is over. Okay, so you can verify. I think here clusters, you see it should go to, it should take some time, and let me wait. So node group first it will delete. So you can see here the node group 1. So you can now wait. Okay, you can see it is deleting the node group now. Okay, so things will go deleted state. Okay, one by one deleting. And I think why one thing is still ready. Maybe is it because of it takes some time.
Sir, please wait, John.
Okay, I think do we need to delete that persistent volume? Because that may have been provisioned here. Some data will be there. So first let me delete that also without any doubt. So I'll delete the persistent volumes we created for Redis. And we need to wait anyhow. It won't happen quickly. Sorry. OPT kickstart Kubernetes. Okay, that is also I'm deleting. May or should speed up that. Okay, so it is happening, but it is happening slowly. So should have done this before itself. Okay, fine. So any questions you guys have? This will take some time to delete. Anyone having questions? You can ask.
John, if we stuck up anywhere in the exercise, right, can we post it in the group chat, or can we contact you separately in the LinkedIn?
Yeah, you can post it in the group chat. That's why group is there. So we will help you.
Sure.
Okay. Okay. Anything you guys want to ask?
John, if there is no question, you may drop the session.
Yeah. I think, guys, is there any questions left where we can get Jenkins pipeline code? Umesh Ravi will post all that. Okay, please wait. If there is no questions, you guys can drop the call. I'm going to stop my presentation. Okay.